Welcome to part 4 of Stl.Fusion tutorial. And this time I'm going to talk about Replica Services. These are basically proxies for compute services that operate on the client side. And interestingly, they, even though they behave like proxies, they take into account the fact that every compute service, every value they compute is backed by I computed. So they try to basically extract all the benefits from this. In particular, when you make a call to the same method with the same arguments twice or 3 times, a remote call will happen only if the computer behind it and the replica of computer was invalidated. So basically, they try to mimic these compute services completely. And let's see how it works. Oh, and by the way, replica services are described by interfaces. So all you need is to declare an interface. In addition, a controller on server, but we will talk about this a little bit later, and I'll explain why. Overall, if you look at this chart, that's how typical web API client works, right? Client usually invokes some method on the client. This client does something to actually make an HTTP request and call usually a controller on server side, which usually in turn calls a server side service, gets the result, and basically that's how you get it back at the client. So, and this is a similar diagram for a replica service. Basically, when you do the call first time, it's very similar, but in addition, what's returned contains a publication ID, and the publication ID is sent in headers. And this publication ID allows client to later get notifications from basically breach API of Stl.Fusion about invalidation, and also request updates to this computed replica via the same channel. In reality, the channel is WebSocket channel, and so you will see this. So there is a Gantt chart describing how the state changes and what basically happens over time. If you want, you can kind of dig into this, but I'll try to keep it short for now. And basically from this point, I'll be showing how it works. So I copied all the code from this page already, and there is a fair amount of code, but in reality, it's not as complex as it may seem. The only kind of complexity there is that we have to create a web server. And so let's see. Okay. Basically, that's our program. We are going to run Replica Service test async method. There are two in this example, and we basically will run the first one. So first we create a host, start the host, and so this stuff is needed to stop basically watchers, or basically stop the tasks that update capture client-side computed replicas and show their state. And what we are going to do is we are going to call we are going to create two computed, one per each call. Basically, we will get a counter for A, named A, counter named B. They're computed, and we'll be watching what's going to happen with them when we increment A first, and then call set async on counter service, and basically this one changes all the counters. because it uses a mutable state inside, like as I shown in previous part. So if you run this service, yeah, let me show first what it produces. Basically, so I just okay. Actually, I just commented out a couple of things, and I think I commented out something that I shouldn't comment out. Oh no, it's actually fine. It's fine because basically, so this fail message, it's a message that tells that a WebSocket connection on server side was disconnected, but nothing bad. Let me actually revert this thing, because this thing routes all logging to debug, and you will see clear messages then. So what you see is, so first we basically let me get back to that. So first we capture a computer behind this thing, right? And counters here is like, it looks like it's iCounter service, but in reality it's a replica of server-side counter service. But anyway, like it's supposed to behave the same. So basically we call its get async method and capture a computed. And the output that corresponds to this is get async call, right? And by the way, you see that the call first reached the controller, and then the actual get async was called. Like later I'll show why. But overall, like that's basically, and once we call this thing, it starts to print messages like this one. Basically, the first message it prints. So let's see what async does. Basically, it runs indefinitely, and it prints the computed state when it waits for its invalidation. When it again prints its state, then it requests its update, and the loop restarts. So it prints its state. So basically, it should print messages like updated, invalidated, updated, invalidated, and so. Oh, and yeah, it will stop. So this cancellation token step is a token bound to stop CTS, which is cancelled in the end. So the first line is printed when we call watch async, right? Then we do the same for the B counter, and the same stuff is printed for each. Here we increment A, right? And again, this call goes to controller, increment async, and then the A computer becomes invalidated. Then since invalidation, since watch async triggers an update, right? Then it so get async was called, but pay attention that controller method was not called. Basically, this means that this call was triggered by a path that bypasses the controller, and in reality, it was triggered by a WebSocket channel. It was an update request sent from the client to server, and server responded with basically the updated version. And so after that, a computer becomes consistent and its new value is 1, right? Then this line calls set offset async 10, and this thing leads to invalidation of 2 values. And then again, via side channel, WebSocket channel, both things gets updated and become consistent. So let's actually see what's going on there, and like what's the code that backs all of this stuff. So create host. We basically create a host builder here. So this thing is kind of, I already said, this stuff is kind of optional. We just don't want to see these messages. That's why we route all logging to debug output. And so what's unusual here? So first we add Fusion WebSocket server in configure services because like we need some channel for Fusion to communicate, right? And we also register a compute service here. So let's see. So we basically register it as this type, but the service is this one, right? Let's click on it. So iCounter service, basically it has one compute method, right, and two regular ones. So these attributes, they are inherited by types that, like basically Fusion looks for inheritance for these attributes, and it makes sense to declare it here. So basically nothing unusual. If you click on the service, it's like almost the same service as in previous example. I think the only difference is that I added this method set async, and this method basically sets offset.value, and offset here is a mutable state, and get async it uses this mutable state. I mean this, right? So when we set offset, all counters are supposed to change. In every other sense, it's like the same service. So we'll start routing at MVC. This thing is basically we tweak serialization here, and so this thing is also from STL. It basically copies all the public fields from this thing to this thing, and that's how we basically copy settings that are necessary for Fusion to serialize almost everything. Okay, and finally we configure a web host where we say that it's we use Kestrel server or Kestrel, I don't know, and we also use WebSocket. So the only unusual part is, I think, this one, right? We map Fusion WebSocket server there. Otherwise, everything is the same. So let's look at what else is there. So we start the host, and then we create client-side services, right? It's a regular service connection. So we made a few. So basically, we want to do this. We want to configure WebSocket client for Fusion, and for the client, we need to tell to which server it should connect. Technically, it can connect to multiple servers. If you click on this thing, basically, it registers type called iChannel provider and default, and like the way it registers, it uses WebSocket channel provider, which has base URL and options. So in reality, iChannel provider just resolves basically a publisher ID to a channel. But like if you want, or like if you need multiple servers, you can subclass this type and let's say override this method. And technically, you can connect to, like, make it to connect to multiple services. Anyway, that's not super important right now. Let's move on. But basically, what we do here is we configure both HTTP client and WebSocket client to make sure that they call correct server. And finally, we add Replica Service, and basically we say that that's the interface and that's the type it should be exposed as. So as you may notice that this is the same type we were using on server, right? The same interface. As for this one is needed to tell how to map methods of basically the type you this type to HTTP methods. So Oh, and I actually forgot one thing, right? When I was talking about server, there is a controller as well. And the controller is what actually exposes the API. So when basically the controller, it should declare the same methods. So basically this is the contract and or like this is the server side part of the contract. And this is the client side part. And as you see, controller just dumps a message to the console once any of its methods is called, and basically writes the call to counters. The only interesting piece here is that for a compute, so like for regular methods, it just routes the call, right? But for compute methods, I mean, if you check out this one, right, get async, if you see how it's declared here, it's a compute method. So for this one, it uses a construction similar to capture, and it calls its own method called publish async. Oh, sorry. So the controller is inherited called Fusion controller, and Fusion controller basically just declares a couple of overloads of publish async. You can check out what it does, but overall, it inspects the header of a request, and if it sees this header Fusion publish, then it adds publication ID and captures the computed. It's basically, then it does all the extra. Otherwise, it just behaves as a regular method. So, and it also uses a special exception filter. Basically, on exception, it does a little bit. So like if you don't use this filter, then headers are not added when an exception is thrown, which is actually bad because the client can capture the computed that still kind of matches to this specific call, and like basically it wouldn't work as expected. But anyway, that's a fairly small amount of code, and overall, so you need a controller, and you need this type that on the client side describes how everything is mapped to the controller. The reason why both parts are necessary is that, like, you don't want to publish everything, probably, right? You want to publish just a subset of methods. So basically, this allows you to control what you publish via Fusion. And second thing is, as you might guess, this is actually a regular API. You can call it using, and there is even an example here. If you click on this video, you will basically, it will show how to call the same API using Swagger or basically any regular tool. So anyway, and I think that's mostly it. Let me get back to this part. So on the client side, we register the same service by using this construction. And as you see, this is enough to basically get this channel working. Let me show you a little bit fancy thing. So I was, as you like, let me show you how perfectly it mirrors what's happening. So I'll copy this stuff right to Notepad, and that's the previous output, right? And then we will replace the service on the client with the same server side service. I'm just like basically, instead of using the replica service right now, I'll be using the compute service itself on the client. Sorry, I want to make a pause here, but let's run this. So let's compare the output. And So that was the output for Replica Service, get async A, then consistent compute, get async B. Let's say the order is a little bit different because this code was running in thread overall, and increment invalidation, and increment invalidation, and consistent again. To invalidate it after set async, so instead of set async, and consistent. So basically, Replica does exactly the same as the original service. Okay, and I guess finally, let's run this test. I have I'll revert this thing, right? And yeah, I'll just quickly comment what's going on there. So this test creates a live state on the client, which depends on our replica service. And again, interestingly, it basically just does the same as here, and shows that, the updates are applied to the live state. So and that's actually like exactly how most of Blazor WebAssembly examples work. They use client-side state, which is produced by using some replica services, and basically they replicate or like they use parts of server-side state. Okay, that's it with this part, and let me quickly see what else is there. I think it's pretty short. It basically shows that like all you need to replicate compute services is what's described here. And I guess what else is interesting? I think you can try to simply run all of this code. Maybe one other thing. So yeah, you need to reference both server and client if you want to run it as a separate project, and also this thing. I think, yes, basically that's it.